Okay, so we are going to look at a question that involves the rate of change, and we are talking about the rates of change. We are just basically focusing on the application of derivatives, because, for example, if you have something like y is equals to 2x plus let me say x squared, then the derivative of that is found by saying dy dx. So you are basically saying the rate of change of y with respect to what? To x. So for the rate of change, for example, if I say dm dn, okay, it's the rate of change of m with respect to what? To n. Okay, so the question is that how is m changing with respect to what? With respect to the n there. Okay, so the question that we have says a cylindrical tank of radius 10 centimeters is being filled with wheat at the rate of 314 centimeter cubed per second. How fast is the depth of the wheat increasing? So the question here that we are being asked is how fast is the depth increasing? Of course, as we are filling the wheat. Okay, so one of the things that we need to take into consideration when you're dealing with such questions, it sometimes it seems like you have nowhere to start from, but just try to look through the question. You find that it's either the formula is there or you have to create the formula for yourself, but in this case we have to try to find the formula for ourselves. So one of the key components of this question is the fact that the the container that we are using is a what? Is a cylinder, is cylindrical. Okay, it's a tank that is cylindrical. What does it mean? A cylinder is something of this kind. Okay, cylinder is something of that kind. All right, so we are filling in wheat inside here, and um, to make this easy, we just try to reason to say, okay, as we are filling the wheat, we are filling up the volume of what? The volume of this cylinder. Okay, and the volume of a cylinder. To remind ourselves, volume of a cylinder is equals to pi r squared times what? Times h. Okay, so now when you have that equation there, when you have that equation, um, when you have that equation, the question that follows is that in that equation, what is changing? Because you're looking for the rate of change of something with respect to another thing. So the question is that is it the rate of change of volume with respect to h, or the rate of change of h with respect to the volume, or something like that? Okay, so looking at what the statement says, the rate. Okay, um we're talking about how fast. When talking about how fast, it has to do with what? It has a component of what? Time as well. Okay, so it basically means here we need to ask ourselves, is it in the volume, the pi, the radius, and the h, what is changing and what remains constant? So for the volume is going to be changing as you are filling the container or the tank with wheat. The volume is going to be changing, it's going to be increasing. What about the height? The height is going to be what? The height is going to be increasing as well. The radius is going to remain what? Constant. What about the pi? The pi is a constant value, it's just to just remain the same as well. Okay, so now we have found out that the volume is going to be changing and the height is also going to be changing. Okay, and that's basically what we are looking for. The height in this case is the depth. All right, so we can say here it's dv. Are you going to say dv dh? That's the question. The answer is no, because volume is changing with respect to what? To time. So it's dv dt is equals to pi r squared. Here we have dh dt as well. Okay, so what we are basically looking for is a rate of change of the depth with respect to what? To time. That's why we are saying how fast is the depth of the width increasing. Okay, so this is now what we are looking for. Is the one that's going to be the subject of the formula. So what are we going to have? So we are going to, if we make the h dt the sub of the formula, we are going to have something like the h dt being equals to dv dt multiplied by 1 over pi r squared. Okay, so what do we have? Our dv dt has been given already. It's there in the equation. It's this one here. We have been given as a 314 centimeters cubed per second. We multiply by 1 over, then the pi is basically a constant 3.1 of 1 1.3.142, then we multiply by r squared, which is 100, giving us something like 314.2. So we have 314.2. So we are saying 314 divided by 314.2. That will give us something like 0.99 with some other values this side. If we round off, you're just going to say your dh dt is equals to 1 centimeter per second. So we are following the units that we have been given. If it was meters per hour, we're going to put meters per hour, kilometers per hour or something, or per minute. We just use the units that we are given here. We are given the radius in centimeters, but we are also given the volume in centimeter cubed as well. Okay, so that's how you go about answering this question. Of course, rates of change. When it comes to rates of change questions, they can be a bit tricky sometimes. As I earlier stated, it's either sometimes you are given the equation, sometimes you're not given the equation. Just a matter of you trying to reason with the information that you have been given. Sometimes you find that the information has been given in terms of words. Okay, in this case, it was just a cylinder. Okay, and we do know, okay, what's the volume of a cylinder? What's the relationship between the cylinder and the values that we have here, such as the volume as well as the depth of the what? The depth of this that same cylinder. Okay, so it's just a matter of finding all those components and putting them together and trying to reason from as many angles as you can, but of course, staying within the range of the question. So that's all from this video. Thank you very much for watching.